What's up YouTube, this is Dennis Panuta for tutorials.eu. In this video you are going to learn about interfaces in C#. First of all, we're going to look at the default interface that exists in the system's namespace, and then we're going to look at creating our own interface and using it. And you're going to learn how to do all of that and fully understand what interfaces are once you're done with this video. So let's dive right into it. In this and the next videos, you are going to learn about interfaces, and they're quite important because they really extend the functionality of object-oriented programming and of classes. So what is an interface? Well, think of interfaces as contracts, where a class that implements an interface agrees to provide implementations for all objects defined by that interface. This means an interface will contain the contract terms, methods and properties, but how we implement them is up to the class that implements the interface. As long as these interface methods are implemented in our class, the interface will remain happy. So interfaces cannot contain any implementations. That's important. So their names are generally prefixed with the I to distinguish them from other C# objects. We create interfaces using the interface keyword. Now let's look at how we can do that in practice. Alright, so there we are back in Visual Studio. So one of the most used functionalities in our C# classes is comparing two instances of a class. This is done using the equals method. This will compare to see if the reference to both of the classes is the same. However, we might want to compare them and see if they are equal based on some other field. So we can achieve this by implementing an interface called Iequatable. So in our case, we have a class called ticket, and it defines one property called duration in hours. So let's go ahead and create this class real quick. Here I have a new class, and actually I can either go here or use the shortcut Control K and C, and I'm going to call this one ticket. So this ticket, as I said, just has one property and a constructor, so let's put them in here. So this property is there to store the duration of the ticket in hours, and then we have the constructor here. And now let's go ahead and implement the Iequatable interface. So therefore we use something similar to what we did when using inheritance. We use the colon and then the interface that we want to use, and you see there are a bunch of them. And the one that I want to use is going to be the Iequatable. Now you need to define of which type of objects you want to compare. So here I want to compare tickets to each other. This is why I need to add the ticket keyword. Now you will notice that Visual Studio isn't very happy because it says defines a generalized method that a value type or class implements to create a specific method. But then the problem that we get here is ticket does not implement interface members Iequatable ticket equals ticket. We can very easily fix that by just going ahead and implementing this. So we could have either used all members, well, to implement them explicitly, or we can just do it manually. Let's do that real quick. So basically I want to return a Boolean that will check if whatever ticket I'm passing, which will be the other ticket, is going to be the same as the ticket that is the one that calls this method. Okay, so the ticket that we create out of this, we compare it to another ticket, and then we want to compare the duration hours. So if they have the same duration, then we will assume that they are the same ticket. Okay, so here we can just go ahead and return the comparison of this duration in hours compared to the other duration in hours. So basically we're saying this ticket has a duration in hours and the other ticket is also of type ticket, so it has a duration in hours, and we're comparing the two with each other, and this comparison, this double equal sign, will basically return true or false. Okay, so this is bool int operator, int left, int right. So what it does is it compares what is left to it to what is right to it, and if they are the same, then it will return true, otherwise it will return false. Basically saying that this method equals will return true if the ticket that calls the equals method has the same duration in hours as the ticket that we compare it with, then return true. If not, then return false. Okay, so let's go over to our program CS and actually use this. So here, what we're going to create is two tickets. One will be T1 and it will be a new ticket and it will have a duration in hours of 10. And then let's actually copy this and create a ticket 2, which will also have 10 hours. And now we can compare them. So here, let's use control right line to just display T2 dot equals and compare T1 with it. So here I'm basically comparing our ticket 2 to our ticket 1 and comparing it using the equals method. Now let's run this real quick and you will see that it says true. And that is usually not the case for the equals method, because if you compare two objects using a normal equals method, so to speak, so if we were not to implement this, let's get rid of this here for a second. So let's comment all of this out and let's compare the two. You see the method still is there. This equals still works because equals is a method that exists in general. And you see now it says false because equals is a method that is inside of the object class, and the object class always has this equals method because every class inherits from object. But now what we're doing is we're implementing our own equals method by using the Iequatable interface. So we're using a specific interface that allows us to compare in our own way, so to speak, and implement our own code. So now if we compare the two, we're not comparing if the object is exactly the same that we're comparing it with, but if in our case the time in hours is the same. So the duration in hours is the same, and then it will return true. So if the time in hours is not the same, let's say it's 6, then it will return false because the duration is not the same for the two tickets that we're comparing with each other. So this was just an example using a simple interface that exists. And as you saw, there are plenty of interfaces that exist automatically when creating a C# project, but we're going to see how to create our own interfaces and use them. Quick pause. In this video, you'll learn something about C#. And if you want to learn everything there is to know that you need for the fundamentals and to become a real C# developer, then definitely check out my C# Masterclass, in which you're going to learn all of the things you need to know about C#. So you're going to learn how to do the basics, how to use object-oriented programming, how to use WPF in order to create your own user interfaces, how to use databases, how to use Link, how to create your own games using Unity, and a lot more. So if you want to become a real C# developer, definitely check out the link in the description below. In this lesson, you will learn how to create and implement your own interfaces with a concrete example, and you will get an idea of why interfaces are used, especially when our classes don't have a relationship with each other and therefore they don't share a base class. So inheritance as such is not an option. Imagine that we are working on a video game where the player can destroy stuff, but everything we destroy will have different behavior depending on what is destroyed. For example, destroying a chair will play some destruction sound and will spawn destroyed chair parts. But destroying a car will play an explosion sound, create fire, and destroy other objects nearby. For our game, we have the following classes: a chair that inherits from class furniture, and a car that inherits from class vehicle. So let's look at those classes real quick. So we have this chair which inherits from furniture, and the chair just has a simple constructor here where we set the color as well as the material based on what is given to the object that is created. But now, of course, this class is inheriting from furniture, which is why we have those properties here, color and material, that we just used in the chair class. And then we have the constructor here, which is the default constructor, where those values will be set by default. So the color and the material will be white and wood by default. And then we also have a simple constructor which uses the color as well as the material to set them by default. Okay, so that is nothing too fancy, but of course we also have a car and we want to be able to destroy the chair and the car, as I stated earlier. So let's look at the car real quick. So here we have the same story, a subclass car that extends vehicle, where we set the car speed as well as the color. So now we are using, by the way, a simple constructor as we do it here, but of course we could have used base here as well. passing the speed as well as the color. Okay, so that is also a valid option, and we wouldn't have to use this in here. So there are two different ways, of course, to go about it. Okay, and then this car is inheriting from vehicle, where of course speed and color have to be defined. So let's look at the vehicle class, and we can see here that this base class vehicle has a speed, a color, a default constructor which sets those two values, speed with 120 kilometers per hour and the color with white. And then we have the simple constructor which sets the speed and the color based on the values that are given to the vehicle object. Also, of course, to the inheriting object such as a car, for example. Okay, so now that we have all of those different classes and we saw how they are structured, let's look at the actual destruction feature. So what is the best approach to create such a destruction feature? If we think about it, we can't add a class to make our classes inherit from it, because C# is a single inheritance language and not a multi-inheritance language. We already inherit from one class. So the car already inherits from vehicle and the chair already inherits from furniture. So it cannot inherit from something else, like for example, the vehicle here. You see, C# doesn't allow this because it cannot have multiple base classes. Okay, a class cannot have multiple base classes in C#. So, plus there is no concrete relationship between a car and a chair to share one base class anyways, because they're entirely different two things, right? If we implement normal methods, called the destroy method, for example, in each of those classes that we have here, it will be hard to maintain. What if we decide to change the destruction system entirely or add visual effects to our destructible objects in the future? It will be a pain to actually go through each class and modify it. Because in this case, we only have two subclasses, so to speak, right? But imagine you have 50 or even 100 different classes, 100 different types of objects in your game. Then you would have to go through every single one of them and adjust the code accordingly. So that is really a burden, and we don't want to go through that. That's why we need to find a better solution. What we need is a way to enforce our destructible behavior on every class that uses it, just like a contract. And if you have watched our video on interfaces, you know that they are contracts that we can create. So the best approach in this case is to use an interface, and we will call it Destroyable. And any class that implements this interface will be forced to follow our destruction requirements and customize it at the same time depending on the class itself. So let's go ahead and create such an interface. Therefore, you can go here to your project, add a new item, and then select interface right here and give it a name. So I'm going to call this one Destroyable. So you can see when using interfaces, you add the I at the beginning of the name of the file to indicate that this is going to be an interface. So let's add this interface. So this interface will just have a property to store the audio file that will be run once we execute the destruction, which will be this destruction sound. And then we just have a method that will destroy an object, and we're going to call this method destroy. It will not return anything, it will just destroy something. So it could, for example, return the graphics that you have, so the objects that you want to display once the item is destroyed. For example, the car is destroyed or the chair is destroyed and so forth. So let's now make sure that our classes are in fact going to implement this interface. And then, of course, implement the interface's content, meaning the destruction sound as well as the destroy method. How can we do that? Well, let's go over to our car, for example. And here our car will need to add a comma here at the top, at the class definition at the top, and use this Destroyable interface, like so. Now, if you add that, you can see that you get an error, which says car does not implement interface member destruction sound as well as destroy. So we can show potential fixes and implement all members, for example. This will create this automatic code for us. So it will create the void destroyable destroy, and it will create the destruction sound for us. So that would be the auto-generated version. But we can also do it manually there's no problem with that. So here, for example, we can implement the destruction sound. Quick pause. In this video, you learn something about C#. And if you want to learn everything there is to know that you need for the fundamentals and to become a real C# developer, then definitely check out my C# Masterclass, in which you're going to learn all of the things you need to know about C#. So you're going to learn how to do the basics, how to use object-oriented programming, how to use WPF in order to create your own user interfaces, how to use databases, how to use Link, how to create your own games using Unity, and a lot more. So if you want to become a real C# developer, definitely check out the link in the description below. And then what I want to be able to do is I want to have a property to store the destroyable objects nearby. So when a card gets destroyed, it should also destroy the nearby object. And this list is also going to be of type iDestroyable, which means it can store any object that implements this interface, and we can only access properties and methods in that interface. So in order to create that, I'm going to create a public list of iDestroyable objects, and I'm going to call them Destroyables Nearby. So now we can go ahead and extend our constructor. So on one hand, we want to make sure that we initialize the sound. So we make sure that we have an explosion sound. For example, let's say we have this sound called car explosion sound MP3. And then we want to initialize the list of destroyable objects. So this will, for example, just be a new list of destroyable objects. And then we just need to also implement the destroy method. So this iDestroyable here at the top, you can see it's still not happy. It's still expecting us to implement the destroy method. So you see, when you implement an interface, you need to implement its members, because the interface here has two members. We need to implement both of them. Okay, so that means that we need to go back here and we need to actually implement the destroy method. So let's really quickly do that. In order to do it, what I want to add in here is going to be, first of all, two statements. I'm just going to use write line statements. I'm going to keep it simple because we're not creating a game here, but we're just trying to understand the concepts of interfaces. So when a car gets destroyed, we should play the destruction sound and create a fire effect. So here we're just mimicking as if we would actually play the sound, and it will just say, okay, playing the car explosion MP3 sound. And then we create the fire. So everything is under fire, everything is burning because the car is destroyed. So now let's go through every single destroyable nearby and actually destroy it. So here we're going to go through every single iDestroyable object that is inside of our list of destroyables nearby. We call it destroyable, so every single item is going to be a destroyable, which is basically just a local variable name. So we say, okay, the destroyable object that will implement the iDestroyable interface will just be called destroyable in our for each loop. So we iterate through it, which means we iterate through the collection destroyables nearby, which is a list of iDestroyable objects, basically objects that implement the iDestroyable interface. And then we just call the destroy method. So basically we create a chain reaction here, destroying everything around everything that is destroyed, and that is also a car and so forth. So in this case, let's say we have two cars next to each other and they have a bunch of chairs next to each other. So the cars will call this destroy method, where they will destroy the items nearby, because, well, it's a huge explosion, right? There is a sound coming up and every item creates a sound. Now you could of course create a timer that it needs until the actual explosion happens after something catches fire, but we're going to keep it simple here. Okay, so we're destroying the other cars, but also the other chairs. So each car will infect other items surrounding it that are nearby. And this could be, let's say, everything that is 10 meters away or 5 meters away or however many inches away, if you want to take the American system here. But that is basically what's going to happen. Now let's look at the chairs, because the chairs are going to have to go through a similar approach, because we also want to make sure that a chair is destroyable. But the destruction of a chair will be very different. Okay, so here we will also add the interface, so the iDestroyable interface. And of course, we need to implement the destruction sound, and that will be a very different destruction, because the chair will just fall apart and it will be shattering wood that you hear. So it will be a very different sound here. Okay, and then of course we want to define the destruction sound inside of our constructor as well. So I'm going to say that the chair destruction sound should be played. It will always be the same. That's why I'm not adding it here in the declaration of the chair. So I'm keeping it simple here. Of course, you could have different chairs that have different explosion sounds. Then you would add it here at the top as a parameter for your constructor. Okay, so now let's actually implement the destroy method. And in this case, what will happen is we will destroy something, and we will first of all destroy the colored chair based on the color that the chair has. We will write that. Then we will play the destruction sound. And then finally, we are going to spawn chair parts. Okay, so in our case, we're just writing it onto the console. But just imagine in a real game how you would do that. Because the best way to destroy something in a video game is not to actually do the physical thing where you do all of the destruction, which is very difficult to build, especially if you don't have a big team that does all kinds of things. Then you would basically just make a big explosion where it's destruction animation, and then you would spawn the destroyed parts or the individual parts that lay around. So you see here, there's no chain reaction coming from this destroy method. So the destroy method implementation for the chair is very different to the one from the vehicle, but both of them inherit from the iDestroyable interface and have to implement the destroy method, and they can do it their own way. So basically interfaces allow us some sort of multi-inheritance, even though it's not really multi-inheritance. Okay, so now let's go ahead and go to our program CS and actually use our newly created classes, because, well, otherwise it's boring, right? So let's go ahead and create two chairs. So we have an office chair, which is going to be brown and plastic, and then we have a gaming chair, which will be red and wood. And then let's also create a new car. So this car will have a speed of 80 and it will be blue, and it will be a damaged car. And then we're going to add the two chairs nearby this damaged car. So we add them as destroyables nearby to our damaged car. So the office chair as well as the gaming chair will now be, if we look at it here, as destroyables nearby. Because when creating a car, this list will be empty, but then we can, of course, because it's a public list here, we can add items to it, which we do. We add destroyable items to it. And why can we add chairs to our destroyables nearby? Well, because a chair implements this interface that we called iDestroyable. This means that a chair is now going to be accepted as an object of type iDestroyable, which means we can now add it as our destroyables nearby. So now we can go ahead and destroy the car. So let's just call the destroy method for our damaged car, so the explosion can take part, the explosion sound can start, and all of the good stuff. So let's run this, and of course this will be more of an adventure game and not so much a game where you see actual 3D graphics or anything. So we play the destruction sound, car explosion sound. We create the fire. The brown chair was destroyed. We are playing the destruction sound of the chair, destruction sound MP3. Then we are spawning the chair parts for our brown chair. Then the red chair was destroyed. We're playing the destruction sound of the chair destruction sound MP3. And then we're spawning chair parts for our red chair. So you see, that's pretty much it. So that's how you can create your own interfaces and how you can use them. And I hope that you now understand what interfaces can do for you and the advantages of interfaces. So an important note hereby. Interfaces are used for communication between two similar or non-similar classes, which do not care about the type of class implementing the interface. Just like how our car communicated with the chair to call the destroy method, all because they just implemented the same interface, as I earlier stated. So while interfaces might seem hard to understand at first glance, they provide us with great perks. Those perks are code readability. So an interface constitutes a declaration about intentions. So it defines the capability of your class, so what your class is capable of doing. If you implement the Iequatable, for example, you are clearly stating that objects of your class can be sorted. Then code semantics. By providing interfaces and implementing them, you're actively separating concepts. An interface defines a behavioral model, a definition of what an object can do. And separating those concepts keeps the semantics of your code a lot clearer. Then you have the code maintainability. Interfaces help reduce coupling and allow you to easily interchange implementations for the same concept without the underlying code being affected. And then we have design patterns. It's the bigger picture of using contracts, abstraction, and interfaces pivotal for object-oriented programming. So human understanding and complex system architecture. So it's really basically just to understand it better as a human being. And then multiple inheritance. So interfaces can be our gateway to use multiple inheritance in C#. So suppose you write a library and want it to be modifiable by users. You write the interface and its class implementation. Other developers who will use your library can still write their own implementation class, which may use different technologies or algorithms that achieve the same result. This is also why we meet so many interfaces in libraries we use, but rarely feel the need to write our own interfaces because we don't write libraries ourselves. On a final note, the important thing is to understand how interfaces are implemented at this point, of course. As we go through different technologies like WPF and ASP.NET in the C# Masterclass, we will start using interfaces more, which will help you understand them better in the future. All right, I hope you enjoyed this video. At this point, you should be able to understand what interfaces can do for you and how you can use them. If you enjoyed this video, then please leave a like and hit that subscribe button. It really helps us out and it will help you out as well because you will be notified about future videos that we're uploading, and we're going to upload a bunch of them, mainly for C# and Unity related topics in the future. And if you love the content and you want to learn in a streamlined manner, then definitely check out the C# Masterclass. You can find the link in the description below. It will make sure that you will be a pro in C# in no time. All right, so check out one of those 2 videos and see you in the next one. Have a nice day.